Let me welcome all of you to the third lecture of drilling and blasting technology. In fact, in our last two classes, you are being introduced with the basic requirements of drilling and blasting. We are trying to find out why we are carrying out drilling and why we are carrying out blasting, how those technologies are evolved, and how we are carrying out those things for basically fragmenting the rock. So, if you are considering this drilling which is carried out for placing the explosive inside the rock, blasting is carried out for fragmenting the rock. So, for both the cases basically rock is the medium. That means, we are utilizing some tool, it may be a drilling tool or it may be an explosive tool for doing something with the rock. So, basically rock is the medium which is subjected to receive the energy from the drill bit or energy from the explosive. So, basically we are dealing with the rock, and that is why I feel it is essential from our side that we should fragment the rock. So, what is our learning objective of this lecture? Our learning objective is that we should understand what is rock and what is rock mass, and we should understand what is earth crust as the rock medium. So, basically this rock is a natural substance, this natural rock is naturally occurring into the earth crust, and we are trying to excavate this for our mining purpose, for our excavation purpose using the drilling and blasting technology. So, we should understand what is the rock, and for understanding this we should have some knowledge about the earth also. So, basically if you are considering the structure of the earth, and the structure of the earth focuses on its layered structure. So, if you are looking into the earth, basically earth is having a layer by layer, and the variations in the density, temperature are existing for all the layers as per the depth. So, as we are staying in the surface, our temperatures are more or less similar to the atmospheric temperature, but the moment we are trying to going deeper and deeper, the temperature are varying. Similarly, the density of the rock medium is also varying. The shape of the earth is called spheroid. The reason is it is little bit larger in the equator side than the polar side. So, if you are considering the diameter radius of the earth, you will find out it is at equator it is 6378 kilometer, whereas at polar it is 6356. On an average, if any time nothing is given, we consider around 6370 kilometer as the earth radius. So, direct observation of the interior of the earth is not possible. If you go through the internet, knowledge is available in the internet, you will find out the deepest hole which is made by the Russian people is approximately of 15 kilometer or something like that. I may be not in a right point to tell you the right value, but it is similar to that. If you can go through search in the Google, you will find out that is the deepest man made hole carried out in the earth crust by the Russian people, that is for experimentation purpose, but the hole is stopped for further drilling and all the experimentation of the hole is also stopped. So, that is the in fact, we will discuss, we have discussed that in our previous drilling lecture also. So, that is the we have the accessibility only up to that depth, beyond that depth we do not have the accessibility, but the interior is no doubt is very hot, and with the depth which is convincingly indicated by the volcanic eruptions. So, volcanic eruptions which are coming out from the deep core of the earth is showing it is very hot. Also we have carried out seismological studies that also indicates that the earth body comprises of several layers and there are several different density materials are existing in those layers. And you can see these layers are distinguished by their physical and chemical properties, particularly the thicknesses, depth, density, temperature, metallic content and rocks. So, basically the layers are existing in the earth crust, they are of different types of nature. The moment some earthquake occurs, the shock waves generated from the earthquake travels through these layers and we are getting some indicative knowledges for those layers. The layer structures of the earth developed during the process of its transformation from the hot gaseous state to the present state. During this process, the heavier materials are sunk and lighter materials are floated, and consequently differential densities material you can find out that density of the earth crust is lesser than the center of the earth. In fact, some places it goes into the density of 18, 20 something like that. To understand the structure of the earth, let us see this video which is downloaded from the YouTube. So, this will give you a better understanding of about the earth crust.
If we could split open our planet, we would see that it is made up of various zones. The earth is approximately 8,000 miles or 13,000 kilometers in diameter from the North Pole to
the section of the earth crust.
The inner core. It is thought to be a solid metal ball about 750 miles or 1,200 kilometers thick. This center core
is 1200 kilometer.
Be at least 5,000 degrees Fahrenheit or 2,760 degrees Celsius. Surrounding the inner core is the outer core.
Then the outer
this
core.
Area is about 1,400 miles or 2,300 kilometers thick,
further
and is
2,300
believed to be
kilometer
molten or liquid rock.
after inner core.
Nickel and iron are probably the main elements of the outer. Next is the mantle.
Then next is the mantle, which is around 2,900 kilometer after outer core.
Think that most of the mantle is solid rock. However, towards the top of this layer, there exists an area of hot, thick, molten rock.
Inner core and outer core are almost in molten stage. Mantle can be also
cool and rigid
named as the different
which we call
layers
the
are
crust.
mentioned as different one. So, finally, after mantle it is crust, earth crust, which is a very shallow one.
Take a closer look at our diagram. We see that on dry
So, the lower part of the
crust
crust is
a mere
called
20 to 60 miles or 30 to 100 kilometers thick.
Sometimes it is
rock
earth
that is
crust is
similar to
varying
the
from
common rock, granite,
60 to 100
makes up
kilometers.
most of this section of the crust. And under the ocean, the crust is a much thinner layer of rocky material similar to basalt. This section of the crust is approximately 3 to 6 miles or 5 to 10 kilometers thick.
So, I think you have understood what is the composition of the earth crust. Now, let us see once again. So, the earth interior is showing as the core, this is the inner core, then outer core, then the mantle, this portion is the mantle, and then the crust part where we are having different formations. So, our activities are limited to earth crust only. So, which is of our point of interest, and you can see the crust is the topmost layer of the earth, its thickness 5 to 10 kilometer. On the continental area about 35 kilometer, sometimes it goes up to 55 to 70 kilometer also. Okay. So, that is available in the earth crust portion, and the mostly the crust of the earth is subdivided into two layers, one is sial and another is siam. upper portion of the earth crust is called as sial. Sial basically consists of rocks like igneous, sedimentary, metamorphic rocks. So, sial part is of mostly the lighter weight material. So, it is basically the basic element is silica. Basically the evolve is from the igneous rocks, then the igneous rocks converted into different other rocks. So, the composition is usually granitic or granodioritic. Sial layers basically chondrite discontinuity separates sial layer from its underlying sima layer, and this discontinuity is a second order discontinuity and is located is about 22 kilometer. So, basically our operations are limited in the sial part, even if you see our activities in sima part is not yet achieved. So, most of our activities in the earth crust is limited to the sial part only. Sima part is the lower layer of the earth crust. This is also called lower continental crust. Its thickness is about 22 kilometer, and it is also having two part, one is outer sima and the inner sima. Inner sima is the inner ones and adjacent to the mantle part, outer sima is adjacent to the sial part, and they are basically basaltic. That means the density is little bit higher if you are considering with the sial part, and this layer is rich with the silica and aluminum. Like sial part it is silica and aluminum, in this sima part it is silica and magnesium. Then the mantle part, basically the seismic activities are mostly carried out in the mantle part. Rarely it is sometimes carried out in the sima part also, but mostly it is carried out in the mantle part, which this seismic activities, and this mantle is basically separating the crust from the inner or outer core, and mantle is separated from the crust with a Mohorovic discontinuity, which is a first order discontinuity. The mantle is having a thickness around 2900 kilometer. Mantle is the major part of the earth, which is which is comprising around 83% of the earth volume and 68% of the mass. So, mantle part is very important, and basically mantle part is creating the mantle part is basically having those tectonic activities. It is the source of region of the most of the earth internal energy, and those energies are often releases with the tectonic activities. It is also the responsible for the ocean floor spreading, continental drift, major earthquakes. The most of the material comprising it is the olivine pyroxene materials, which exist in solid state in the high temperature also. Within the mantle a number of second order discontinuities are also there, and often these stresses are build up along these discontinuities, and with the breakage of those the energies are released. Density break at 80 kilometer of the depth changes the density from 3.3 to 3.87. So, where the earth crust our normal density is varying around 2 to 2.4, in the mantle this density reaches up to 3.3 to 3.8. Gravity break at 150 kilometer depth. So, gravity changes from 984 centimeter per second square to 974 centimeter per second square. It reaches at depth of 1200 kilometer. So, at 700 kilometer depth there changes the capability of the materials in storing about elastic strain energy. So, that is why these mantles are very significant one, which basically produces the earthquakes and different release of the different seismic energies. 950 kilometer depth, it marks the lower limit of very rapid rises in the velocity of seismic vibrations, and 1200 kilometer gravity attains its minimum value of 974, thereafter it rises 1068 centimeter per second square at core boundary. So, that is why this mantle part, which is important for seismic activities, but not of very much interest to our part. Our rock excavation is limited to the outer core, that is the CL part of the crust only. So, the core, for our sake of knowledge, let us understand the core is separated by the Gutenberg Witchcraft discontinuity, and this it is the core is considered up to the center of the earth, and the outer core is 2900 kilometer to 4982 kilometer depth, and it is considered to be a state of homogeneous fluid. That is why the seismic wave, the body seismic wave, S wave, CR wave does not transmit through this medium, it transmits through the outer medium only. However, P wave may travel from this medium. The middle core is existing around 4900 kilometer to 5100 kilometer, and this is in fluid or semi fluid state, and inner core is very in fluid state, and often the density of the inner core rises up to 18. So, inner core is called knife, and its thickness is believed to be 1250 kilometer. So, basically this is the comprising of the earth. In the next class we will discuss about the geology of the rock. So, the understanding of the earth is basically showing us that all our activities are limited to the crust of the earth, and that is also the outer crust of the earth, which is called as the CL. So, on the very surface part where the density is low, on that part only we are carrying out our rock excavation activities. So, we will understand the rock and rock geology in the next class. Thank you.